This video is on finding the average value of a function. Before I write out a formal definition, I really kind of want to show you what the average value represents, and then we'll talk about the formal definition. So I'm going to draw this out as a sketch on an x and y axis. And we'll say we have some sort of function here, which we'll call f of x, over some interval from a to b. Now, when we're looking at this, when I want to find the area under this curve f of x, what I normally would do is I'd say, okay, if I was trying to find the area under the curve from here to here, from a to b, I would say let's use the integral. I'd say the integral from a to b of f of x dx, and that's equal to, well, you would have to know what the function was, take the antiderivative, and then evaluate. Now, what I want to do when I find the average value is I'm actually going to look for a rectangle from a to b that has a height that has the exact same, that gives the exact same area as this integral. So the integral is what I've drawn here in blue. This would give us the area under the curve there. I'm going to look for the height of a rectangle, which we're going to call, and you'll see why later, I'll call it y sub AV for y average. And we're looking for a rectangle that actually goes from A to B. All right? And this rectangle that I'm drawing in red would have the same area as what was underneath the function f of x from A to B. So I'm looking for a rectangle that has the exact same area as the area under the curve. Well, what would the area of this rectangle I just drew in red be? Well, it would be the height, the y-av, right, the height of that rectangle, times, the base, right, the base down here. This a to b is really the distance, is b minus a, right? That's how far apart they are. So it's really y average times b minus a, whatever that distance is, right? If this was 3 and this was 5, 5 minus 3 would tell you they're, 2 units apart. So this integral is equal to this area. We're trying to find a rectangle that has that. So what I really want to do is I want to figure out what that height has to be, what y-av has to be. Well, to isolate y-average here, what you're really going to do is you're going to divide both sides of this equation by b minus a. And I'm going to divide here by b minus a. This gives us what the height needs to be. The height of this rectangle, y-average, has to be the same as the integral, right, the definite integral from a to b, divided by whatever that b minus a distance was. Which, in a more compact way, we would write this as 1 over b minus a. When we divide by b minus a, we could say it's the same as multiplying by 1 over that. So it's 1 over b minus a times the integral from a to b of f of x dx is equal to y-average is equal to the height I need to get a rectangle that has the same area as what was under the curve. So this formula here is actually what the average value of a function is. It's representing, maybe I'll write it in words so you see it. This is the height of the rectangle over that interval from a to b. That gives the same area as the integral from a to b of f of x dx. In other words, it gives the same area as what was under the curve over the same interval. So it's finding the average value of the function over ab is really what we're finding. So that's how you find it. The formal definition, is really the exact same thing I just said out loud. It just, writes it up in a little more compact form. So for my definition here, I'll just say let f be continuous, CTS for continuous, over the interval A to B, right, closed, right, so over the closed interval from A to B, the average value of f, which in this case we call y sub AV, right, y av over A to B is, and it's this formula we just did, right? So y av is equal to 1 over b minus a times the integral from a to b of f of x dx. And this formula shouldn't be too difficult to remember. Mainly you're just taking whatever the definite integral was over the interval, and then you're dividing by b minus a, the difference. So let's look at a few examples. So if I were to say, in this example here, if I said find the average value of y equals x cubed plus 4 over the interval from 2 to 8, right? Closed interval from 2 to 8. You don't have to graph it, you don't have to show the graph. The picture I showed earlier was just to give you an idea of what it looks like. But for our solution, right, I'll call it y av, that's the notation that our textbook uses. Right, the average value is equal to, well, remember, it's 1 over b minus a, right? So this is a and this is b. So it's 1 over b minus a, which will be 8 minus 2, times the integral from a to b, 2 to 8, of this function, x to the third plus 4 dx. Now once you've written it out, all you have to do is evaluate what you have, which isn't usually too difficult. This is equal to 1 over 8 minus 2 is 6, times the antiderivative of this. Well, antiderivative of x to the third would be x to the fourth over 4, plus the antiderivative of 4 is 4x, and we're evaluating this from 2 to 8. And basically just keep the 1/6 in front and then keep working through it as you simplify. So we have 1/6, remember it's times the whole thing, so it's 1/6 times, and then we're substituting 8 in first, so we have 8 to the fourth power over 4 plus 4 times 8, minus, remember if you're subtracting here you need parentheses around what you're about to sub in. We didn't need parentheses around the first part because there's nothing to be distributed through. This big bracket separates the 1/6 that will need to be distributed through later. So minus subbing in 2, so we have 2 to the fourth over 4 plus 4 times 2. So this was substituting in 8, we did that there, minus substituting in 2, make sure you have parentheses around it because the negative belongs to all of it. And then evaluating, we have 1/6, we have 8 to the fourth over 4, you can do it on your calculator, 8 to the fourth power is 4096 divided by 4 gives you 1024. So we have 1024 plus 4 times 8 is 32, minus here, 2 to the fourth is 16 divided by 4, so that'd be 4 plus 4 times 2, so plus 8. Remember that's still in parentheses because that minus belongs to all of it. We can combine like terms here. We end up with 1/6 times 1024 plus 32 will give us 1056. Minus 4 plus 8 is minus 12. We don't have to distribute. If I add those together, then it's just minus 12. And what does this equal? Well, you have 1/6 times 1056 minus 12 is 1044. And if you did 1044 divided by 6, you get 174. So this equals 174. Now remember what this is. This would be the height of a rectangle, right? That's what this gives you, the height of a rectangle that has the same area over the interval from 2 to 8 as this integral that we just used here. So you're finding the average over the interval. It's essentially what you're saying is, okay, take the area here, and then, what's the average going to be? It's 1 over 8 minus 2, which is 1 over 6, right? It's dividing by the length of the interval, essentially. So we get 174. Don't put square units on there or anything like that. This is the units of y, right? It's the height. So 174 is the average value for y equals x cubed plus 4 over the interval from 2 to 8, right? It's the average. Another way of looking at it is like the height of the function. Let's look at an applied example. So in this example, we'll say a company determines its marginal revenue per day is, and they give us r prime of t, right? Remember, marginal revenue is the derivative of revenue, so r prime of t equals 75e to the t minus 2t, and they also gave us this initial condition. They're saying r of 0 equals 0. So the revenue at 0 days, right, this is the original revenue function, not the derivative. The original revenue function at 0 days is $0. All right, so where r of t is the total accumulated revenue on the teeth day. So they gave us the marginal revenue. They also are going to tell us the marginal cost. The marginal cost per day is given by c prime of t. Remember, marginal cost is the derivative of cost. So c prime of t equals 75 minus 3t, where they're telling us c of 0, the original cost function, equals 0. So at 0 days, the cost is $0. And they say where c of t is the total accumulated cost in dollars on the teeth day. All right, so all of that is just information, right? I didn't ask you a question yet. But it's important to know, I feel it's important when you write this down to understand what you're looking at. And that's why we kind of went through it slowly together. So they've given you the marginal revenue function. They've given you the marginal cost function. And the first part of this will say find the total profit P of t from t equals 0 to t equals 10. So let's make sure, when I say this, find the total profit P of t from t equals 0 to t equals 10, the first thing you got to recognize is that, the profit function P of t, they didn't give us anything about profit, right? They didn't tell us the marginal profit, which would have been the derivative of it. But we do know some information, right? We know that, if I was trying to find P of t normally, that's equal to the revenue, R of t minus C of t, the cost. And if I was taking the derivative then I know that P prime of t, the marginal profit, is equal to taking the derivative here, right? So R prime of t is the derivative of R minus C prime of t is the derivative of C. So we know that the marginal profit is actually equal to the marginal revenue minus the marginal cost. Knowing that means that if I can take the antiderivative of the marginal profit, I can get the profit function. So when I do this, right, what we're really going to do is we're going to start off by saying, okay, how do I get p of t? Well, that's going to be the integral of p prime of t. Well, what's p prime of t? It's this. So it's the integral of r prime of t minus c prime of t dt. Again, remember why this is true. It's because this piece in here is p prime of t, right? So if you take the antiderivative of the derivative, you get the original function, p of t. So we want to find p of 10, essentially, right? We want to find what's happening over the first 10 days. So this is general. If I want to be specific, we'll say we're going to look for p of 10. For p of 10, that means we want the integral from t equals 0 to t equals 10. That's what's really going on here, right? This, even if I didn't write p of 10 here, the integral from 0 to 10 is the profit over the first 10 days. That's what we're really talking about, from 0 to 10. If this had a lower limit that was different, let's say it was from 5 to 10, it would be the total profit accumulated between, day 5 and day 10. So making sure you understand what we're finding here, they said from 0 to 10, so it's the profit over the first 10 days. Let's substitute in r prime of t, right? We know what that is. They gave it to us up here. The marginal revenue, 75 ET minus 2t. So 75 e to the t minus 2t minus the marginal cost. We have that above. The marginal cost was 75 minus 3t, so minus 75 minus 3t. Make sure you have parentheses around that because you're subtracting that whole function. And then make sure you put dt at the end because you're doing this with respect to t now. You need that. That's correct notation. And then we're going to simplify this and evaluate. So this is the integral from 0 to 10 of distributing the negative sign through. We would have 75 e to the t minus 2t minus 75, distributing the negative to there, and then negative times the negative makes us plus 3t. And then this is all with respect to t. Simplifying further, you can combine like terms in here. This will give me, if I'm looking at this, the integral from 0 to 10 of 75 e to the t minus 2t plus 3t is just plus t, and then minus 75 stays minus 75. And again, we haven't integrated yet. We were just simplifying the integrand, the inside there. Now we're ready to take the antiderivative. When I integrate this, 75 e to the t power, 75 stays in front. Derivative of e to the t is just e to the t, remember, plus the antiderivative of t squared. The antiderivative of t squared, or the antiderivative of t, sorry, would be t squared over 2 because you're adding 1 to the power, divide by that same power. Minus 75 becomes minus 75t. Remember, if you have a constant, the antiderivative is just the constant times your variable, which is t in this case. And we're evaluating this from 0 to 10. And then what do? Well, I substitute in. Substituting into this, remember you're subbing in 10 first, minus substituting in 0. I'll write it down here. All right, so we're continuing on down to the next line. We have 75 times e to the 10th power plus 10 squared over 2 minus 75 times 10. So that's me substituting in the upper limit of integration, right, into the antiderivative we have here. And then we subtract off, substituting in 0. So make sure you put parentheses around it because you're subtracting this entire thing off. So it'll be 75 e to the 0, all right, and then plus 0 squared over 2 minus 75 times 0. Let's talk about what this equals. First off, sometimes people just cancel this out because they subbed in 0. You can't in this case. You have 75 e to the 0. Remember, e to the 0 is 1, right? E to the 0 equals 1. So this is really 75 times 1 here, which will make that a 75. So substituting into this, we'll simplify some of it. We have 75 e to the 10th. I'll leave that as is. Plus 10 squared is 100 divided by 2, so that would be plus 50. Minus 75 times 10, so minus 750. And then minus here, these terms go to 0, right? That's 0, that's 0. So you have minus 75 times 1, which is just minus 75. All right, if these didn't go to 0, you'd have to distribute the negative through all of it. Combining our like terms, this gives us 75 e to the 10th plus 50 minus 750 minus 75. Well, plus 50 minus 750 is a negative 700, minus 75 is negative 775. Okay, this is exact. All right, this answer here I have is exact. But let's talk about the context of the problem. The problem itself is asking me for the total profit from day 0 to day 10. This is kind of, an ugly form to talk about profit in. So let's give, the estimation, the approximation in terms of money. You could type this in your calculator. It'd be 75 times e, so a second e to the 10th power, and then subtract 775 from that, and end up with this number here, which is a big number. It looks like we got, what, $1,651,209.93, and there's a 5, so 94 cents. So this equals, if I'm writing this down, I have $1,651,209.94. Right, and what did I find? Well, that's money, right? So we knew it was money, and this is the total profit over the first 10 days. So that's what we found. So making sure you understand what we found there. Now, we did this whole example. We didn't actually use any of the things we just talked about in the section about average value, but part B, we'll talk about this. So, part A was just find the total profit. Remember, we knew the marginal profit because we knew the marginal revenue and the marginal cost. And then we worked our way up from there. If we know the derivative of profit, then we can take the integral of that to get the profit. So it's the total profit over the first 10 days because we were going from 0 to 10. Now in our next part B, which I'll write in the next page, we'll talk about the average daily profit. So part B of this example, it says find the average daily profit over the first 10 days. So just thinking about this a little bit logically, if I said, this is the profit over the first 10 days, how would you find the average profit over those 10 days? Really, it's as easy as saying, okay, I would just divide by 10, right? Just like, you normally would if you were trying to find the average of something. You just divide by the total number of days you have, and you'll find the profit over those number of days. So an easy solution is, divide the answer from A by 10, which is probably the easiest way to do it. We'll do it here just so you see it. So part A, the answer was, we had 1,651,209.94. That was the total accumulated profit over the first 10 days. Dividing it by 10 will give us, the average per day. Dividing this out, really, when you divide this by 10, you're going to move that decimal place over 1. This ends up equaling 165,000, right? Because this all gets moved over. So 165,120 $120. Just moving that over. and it'll be 99 cents. Now this $165,120.99, that would be per day, right? Because it's the amount of profit per day. So the 1 million number, right, the 1,651,209.94, that was the total accumulated profit over the first 10 days. This is saying, okay, divide that by 10, this is how much you made in profit per day. You could also have used average value, because really all I did is when I divided by 10 here, right, think about what I did. If I used average value, we'd say YAV, right, is equal to, well, it'd be 1 over B minus A. B minus A would have been 10 minus 0. Remember, our interval was from 0 to 10, so it'd be 10 minus 0 over the integral from 0 to 10 of P prime of T dt. Right, this is going back to, you know, our average value formula that we talked about earlier. Right, it'd be 1 over, our A and B would be 0 and 10, so it'd be 10 minus 0 over the integral of that. That's how you find the average value. And that's fine, it's the average daily profit. But, you know, we know what this is. That was what we calculated in part A, right? The integral from 0 to 10 of P prime of T. I wouldn't expect you to do that all over again. It really is, right, what we found down here. This value came from the integral, right? This is of P prime of T. So once you have that, you really can say, okay, well, this is equal to 1/10 times, well, what was this integral? Well, this integral was that, you know, 1,651,209.94. Well, 1/10 times that is saying this divided by 10, which again gives you that answer. So, you know, we found the average value, you know, in a roundabout way when we did this first part. We used our, you know, common knowledge of how to find the average of something. But it really means the same thing as finding the average value here. And if you did this, this would be completely correct. And, you know, really what they're probably trying to get you to do, I just want you to have an understanding that it's really the same thing, right? This part here was the accumulated profit when we evaluated it, and then dividing it 1 over the interval we're talking about will give us how much per day. Now, if they had told us originally that, you know, we wanted to use from t equals 0 to t equals 5, or if they want to use from t equals 5 to t equals 10, if they use t equals 5 to t equals 10, this would have been 10 minus 5 here, and this would have been 1 divided by 5 here. And this would have been from 5 to 10, so this would have given you the number we would have gotten here would have been different, but it would have been the profit from day 5 to day 10, and then averaging that out, it would have been 1 over 10 minus 5, which would be 1 over 5. So, you know, it's not always going to start with 0. That's important to recognize. But, you know, average value is helpful to determine things like this.